Alright, today we're going to take a look at section 4-5 using computations with scientific notation. So let's go ahead and start here. When we're computing with scientific notation, what that means here is we're doing math problems where both numbers have scientific notation in them. So just a quick review here. This says name the property represented by the sentence below. So you have 3 plus 6 plus 4 equals 6 plus 4 plus 3. Notice how these are rearranged. So they switch the order of those. That's the commutative property. So again, if you're adding or multiplying, this is from several sections ago, but if you're adding or multiplying, this works. You can rearrange this stuff and it still equals the same thing. So we're going to use that property as we work through some of the numbers here today. So in this question, this says the SR-71 Blackbird is one of the world's fastest airplanes, and it's capable of traveling at a cruising speed of Mach 3, or 3 times the speed of sound. So if the speed of sound is 760 miles per hour, so this says express 760 in scientific notation. Okay, so we're saying 760 in scientific notation, so I moved this, our decimal place is right here. I know we don't see one in here, but it is right on that end. So what we're going to do in order to get it into scientific notation is move that decimal over 2 places, so it's between the 7 and the 6. And since we moved it over 2 spots, we're going to write 7.60 times 10 to the second. So this exponent tells us how many places we moved that decimal. Hey guys, really quick, 10 to the second power, isn't that, we'll see if I can do this, I don't know, 10 times 10, and doesn't that equal 100? So if you're ever confused about how to do this exponent, just think about here, this answer, or this number, times this one should give you your original. So if we took 10 squared, that's 100. 7.60 times 100 would give us 760, so that means we did it right. Okay, so I think I accidentally did that. So for this next one, it says, suppose this Blackbird travels 150 hours in a month. Express 150 in scientific notation. So again, there is no decimal in the number 100, so I went ahead and penciled one in there at the end. And then what we're going to do is, if we need to put it into scientific notation, we're going to scoot that decimal over 2 places, because scientific notation rules mean we need to have 1 digit in front of the decimal place, and it cannot be a 0. So that means we're not allowed to put the decimal place after the 5, because then there's 2 places there, two numbers in front of the decimal, and it certainly can't go way over here after the 0. So we need 1 non-zero number, so 1, 2, 3, 4, 5, 6, 7, 8, or 9, in front of the decimal, one and only one of them. So in this case, we moved it over 2 spots, so we're going to say times 10 to the second. So now it says here for the next question, write a multiplication expression using the numbers in exercise 1 and 2 to represent total number of miles traveled by this Blackbird in 1 month. And Blackbird, they mean this fighter jet. Okay, so what we're going to do here, we're going to take this value, 7.60 times 10 to the second, and the next thing we're going to do is 1.50 times 10 to the second. So if this is our miles per hour, and this is the number of hours, this should give us, if we said miles per hour times hours, it should give us miles. So that's how I decided that we were going to multiply. Plus it says write a multiplication expression. So we're taking those 2 numbers and multiplying them together. Hey, really quick, do you remember in the last sections that we were talking about, if you did something like this, 4 squared times 4 to the 5th, if the bases are the same, you can rewrite the base here, and then you take your exponents and add those together. So 4 squared times 4 to the 5th ends up being 4 to the 2 plus 5. And that ends up being 7. So what I'm thinking here, we can rearrange this stuff so that we can do this a little bit more easily. So this says you can use the commutative properties, which means you rearrange the numbers, and the associative property, which means you change where the parentheses are, to rewrite the expression in exercise 3 as this. Do you see what they did? They took 7.60, well, they didn't write the 0 because I guess it doesn't matter. It doesn't change the value of the question, the number. So they took 7.60 times 1.5 and put those together times 10 to the second times 10 to the second. So if you rewrite it like this, I'm seeing this, and it looks kind of like this. So if you're multiplying them together, you can just add those exponents. So what's 2 plus 2? Isn't that 4? That's what I put here. And then this part I used a calculator. 7.6 times 1.5, and I got 11.4 for this. So now it's saying write the product in exercise 4 in both scientific notation and standard form. Do you see how this is an 11.4? That's not scientific notation. We're not supposed to have 2 digits in front of the decimal place. So what I need to do, I need to change colors here. What I need to do is I need to take this and move it over 1 spot. So if I did that and I moved it over 1 spot, I changed this to a 5. So we said 1.14 times 10 to the 5th. Okay, that's supposed to be an arrow, sorry. 1.14 times 10 to the 5th, and then that in standard notation would be 114,000 miles. That's how far this fighter jet could travel in a month. Okay, so let's look at some more examples here. We're going to move on to the next page. So this one says here, for each product, fill in the boxes to show how you would apply the commutative and the associative property. So what we're doing is we're making this easier on ourselves. You could plug this whole darn thing into your calculator, but there's a good chance that we'll miss something, like accidentally miss the multiplication symbol or accidentally put this as another number instead of an exponent. So in order to make sure we do this right, it's best to do it this way, and then we can shorten up what we plug into our calculator. Check this out. 10 to the 5th and 10 to the 3rd, let's group those together. And then 1.5 and 6.2 will group together. If we were to do this now, we could say whatever 1.5 times 6.2 is, we plug that into our calculator, and then we could say times 10 to the 5th and 10 to the 3rd. 5, 6, 7, 8. So this could be 10 to the 8th, right? I didn't mean to do the decimal, sorry. 10 to the 8th, because that's 5, 6, 7, 8, so I'd put the 8 there. So all you would have to do is in your calculator type in 1.5 times 6.2, and that would go here. I'm going to guess it's like 8 something, I don't know. It doesn't ask us to solve it, so I'm not going to right now, but you certainly can. So this next one is a little different because we're doing a division problem, but I see that there's 10 to the 6th and 10 to the 4th. So what I'm going to do is I'm going to group these first numbers together, 1.6 divided by 3.2, and then this is times, because I see that it's multiplying on both sides, so this is a times in between. 10 to the 6th, 10 to the 4th. So I put 10 to the 6th and 10 to the 4th. So if we were to do this problem, we'd take 1.6 times divided by 3.2 in our calculator. And then this would be 10 to the, what is 6 minus 4, right? We would, here they're multiplying, so we add the exponents. That's how we got 8. But here, do you see that it's division? So now we subtract. So you would say 6 minus 4. Isn't that 2? Yeah, it's 2. And so your final answer would be take this and then put it here, and that's your final answer. Whatever 1.6 divided by 3.2 is, that goes here. And then you'd probably have to put it into scientific notation because it would be a decimal. Anyway, this is the next step. So the question asks us for number 3, how do you divide two numbers written in scientific notation? How do you divide two numbers written in scientific notation? So I started writing this. I don't know where I was going with the rest of that. What I said was divide the first numbers of each. Then what else could we say here? Can we say, I don't know if I'm going to try writing all that. Let's try typing. Whoa. Let's get something a little bit more manageable. Okay, so maybe what I would say here, let's change this so it's nice in the same color-ish. Never mind, we'll do purple. So it says divide the first number of each, then, what do I say? Multiply by the quotient. That's a good word. Quotient of the second set of numbers. And those would be like the power by the quotient of the, let's do of the powers of 10. Does that make sense? So quotient means the result in a division problem. And when we say powers of 10, we're saying this guy. So what we would be doing is divide the first numbers and then multiply by this part that's divided. So divide these powers of 10. Okay, let's look at the last part here. So this is saying for each expression, circle the number that you'd rewrite in order to subtract, add or subtract, then rewrite it. So I'm seeing here, sorry, a notification coming up. Okay, there's another one. So this says here, rewrite the numbers so that both numbers have the same exponent. Okay. For each expression, circle the number that you would rewrite in order to add or subtract. Do you see that this is to the 5th and this is to the 4th? No, you would rewrite in order to add or subtract. I don't know if we do need to rewrite it. Couldn't we just do... Oh, because if we're adding or subtracting, okay, just kidding, hold on. If we're adding or subtracting, we want the exponents to be the same. Up here with multiplying and dividing, it was easy enough because you could add the exponents or you could subtract the exponents, but when the numbers themselves, when we have the addition or subtraction problems, these need to be the same. So here's what I'm going to do. I'm going to take, I'm going to pause right here actually. I'm going to grab, so I don't make a mistake here. Hold on. Actually, you know what? I'm going to do this in the next video. So pause right here and then play the next video so I can talk through this one.